go and we can spend as much time as we can reviewing. 3, 2, 1. I agree. Don't forget, today, not so much. Office hours are over today. Thank you to the one person who came to office hours and studied. That's a good thing. Tomorrow, though, after 2, I have classes from 8 a.m. to 2 p.m. But after 2, we will have office hours pretty much all day. If you have questions, until 6. Also, today, you're more than welcome to stay for an extra hour if you don't have a class. If you do go to the class, don't miss class. But we'll just do the exact same thing we're doing right now for another hour with a different class. Cool. Let's go ahead and get started. I'll also post this whole thing online on YouTube. Hopefully right after this, it should be recording. Yep. Hopefully right after this, as soon as I can, I'll get it up so you can watch this class or the other class or go back and work some problems. Cool. Yeah, let's get started on our review. Did anybody have any spots where they are already struggling with a type of question or a specific spot in a question? It's a short YouTube video. That's great. When you go and you want to look at this online, I'm going to post this to Blackboard. When you look at the review, it might not look like there's answers here. That's because they're all going to be at the bottom of the page. I'm just going to copy and paste and put the worked out stuff at the bottom. Just so you know, I'll write a note at the top that says go to bottom, so you know that. But just a little FYI. Okay, what's up? Thank you.
In class yesterday, B theoretical equations is no solution, but we didn't get a chance to look.
Okay, so let's look at B for radical because that's a super possible answer for radical equations. And not only that, but you have to check. So you actually might get an answer. And in B, I think you do. I think you might get an answer like -1 or something. But you have to check the radicals. That's like the one. I mean, you should check all of your work. But if you're running low on time and you're struggling to finish the test, you have to check radicals. Whereas, I don't know. I'm not going to tell you any other kind that you don't have to, but let's get started. Thank you. Thank you for coming with the question. I appreciate that. We're going to work through B and see what happens. I might give us the short 3-step way to solve. Step 1. Actually, does anybody kind of know or remember or have an idea of what square both sides? Actually, no. That's not step 1. Step 1 we don't have to do for this problem, but there is a step 1 that comes before squaring. Get the square by itself. So square root alone. No, we're doing B. I'm just saying the step is still there, even though you don't have to do it, because I don't know what your test is going to look like, and I don't know what your homework looks like. So step 2 is then square both sides. Well, this is a review. This is not how to. Who cares about the answer to this problem? This problem's not on your test. Right? Okay, so we're going to square both sides, though. You are right. That is the first step of this problem, for everybody that was yelling, is square both sides. We end up with r squared equals parentheses, because I like them, -1 minus 2r. I guess we didn't really need those parentheses, but sometimes they're good to write, just in case there's something on the outside that needs to be reduced or whatever.
I think it's going to be a quadratic.
It looks like a quadratic. Get rid of the parentheses because they're not doing anything. There's nothing to be distributed. There's nothing to be FOILed. There's nothing to be factored. So now we'll move everything to one side. I'm going to keep the r squared positive. I was talking to Emily. I was talking to Emily about that this morning. She said, how do you know whether you factor out a negative or not? And personal preference and a good suggestion is just keep the first term positive because it's prettier. It's always nicer to have the first term positive. So we'll move both of these over by going +1 and +2r. And what happens to those? What happens to those on the right side? They don't cancel out. It's a terrible way to say it. We were talking about that this morning too. But what do they actually do? They equal to zero, equate to zero, turn into zero. But I know, but we were talking about that because turning into zero canceling is way different than. What happens to these twos?
Divide it. You divide it.
What happens? No, what happens to the twos? What would you say? They cancel out, right? But what do the twos actually turn into? And in the other case, the twos turn into. So we use the word cancel for two different things, and we were asking about that this morning. And like, well, how do you know which one it is, 1 or 0? So instead of canceling, talking about exactly what they do is a probably pretty good idea. So they turn into 0. I know this is way more than we need to do, but so now we're at r squared plus 2r plus 1 equals 0. And that does have a nice neat factor. Look at the first term for the first two terms, r and r. Look at the last term for the last two terms, 1 and 1. Does that add up nice and neat to make the middle? If you put pluses, yeah. And so we could write it as a squared instead. So it could look like r plus 1 squared. So what's our solution? Or what gives us 0? If r equals -1. So you're taking your test, and you're doing this problem, and you get an answer, and you go to the next one, right? And what you've done there is forgot this really important step that matters a lot. Oh, I should have said step 3. Step 3 is solve. And if you're like, what does that mean? Well, that's all the steps from the previous chapters. So we did chapter 1, chapter 2, chapter 3. We could write 100 steps because we could write factor, we could write use slide and divide or quadratic formula, but solve. You know how to solve if you've worked through the first few sections. Solve. Step 4, though, is really important. For square root problems, also known as radicals, you have to check. Because we didn't get any red flags during the problem. I didn't get a single red flag during that problem. It felt normal. But it's not. Because watch what happens. Our original problem was r equals square root -1 minus 2r, right? Plug and chug, we get -1 equals square root of -1 minus 2 times -1. So -1 equals the square root of 1. Is -1 the square root of 1? Wasn't that? Because that would have been square root of -1 plus 2 equals square root of 1. This is the work off to the side. Is -1 the square root of 1?
It could be. It could be plus or minus.
No, because they wrote the problem. They printed it on a piece of paper, so they didn't give us plus or minus. They picked plus. They just didn't write it. If we write the square root, we got to put plus or minus. If they write the square root, they picked plus for us. It's there. It's just invisible. Because they would have put a minus on if it was minus. So if you see a printed out square root, they picked it for you. If you introduce the square root as you're solving the problem, if you write it for the first time, so you look down here, did we ever write a square root when there wasn't one? No, we actually took one away. So because they've decided that that's the positive version of the square root, it doesn't count. Now, fun little fact, if they would have given us this equation and there was a minus sign right there, it works. Good solution, because that's the solution. It might actually not end up being -1. It might be something else. We didn't solve that equation, but because they picked the square root, they told us it was positive. So x, 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 no solution. You can do that too. You can do no solution, extraneous solution, does not exist. I'm not super picky. Heck, you could do this. An empty set, a set with nothing inside of it. Like, that's a set of no numbers. I'm okay with whatever. No, don't put a big ol' X. That looks like X is the answer. Yeah, this is funny. If you were to graph these two things and look for an intersection, this is just a quick way to see it. Like if you were to graph the line that's just the normal identity function, which is a line, and then you were to graph this square root function, I don't know exactly what it looks like, but it looks like it's shifted to the right one, vertically reflected or horizontally reflected, and maybe like something like that. I don't know 100%, so don't mark me on that. Looks like it should be horizontally reflected or something. But finding their intersection without it being flipped would be really hard. Okay, you got one? Yeah.
I got some stuff that's like on the actual homework.
That's fine, because I'll let you know how similar it is or not.
Okay, this was like the distance problem, where it's fine.
Oh, yeah. Okay, we can do distance. I thought I killed this. That's my fault. What section is that in?
2.6. It was like one of the last problems.
How did distance get in 2.6? I don't know, but we can still do it. Probably won't be on the test, though it uses a formula that we did cover in class. It just might be a little weird. Distance is a weird way to say it. So 2.6 distance. Okay, hit me with the problem.
It's find x such that the distance between x2 and -1, 2 is 8 units. There are two solutions, A and B, where A is less than.
I'm going to call this xy. The distance between those two is equal to what? 8?
So between x2 and -1, 2 is 8 units.
He pulled it from the homework. Oh, so this is, we even know this y value, which is 2? Oh, that's even better. Like that? This is from the homework. He was just asking the homework. 6? So Pythagorean theorem is what this works out of is the Pythagorean theorem, which was in this section. It just worded a little weird to kind of trip you up. Well, I'm not going to answer that question because I've already answered it very clearly and explicitly when I handed you that piece of paper. Yeah, this is the Pythagorean theorem worked out. So yes, it's weird and annoying, but we can do it, and we did learn it in class / in the chapters we covered. So these are 2 points, right? There's a point. Maybe I'll draw the graph first. There's the normal Cartesian graph. One of the points is -1, 2. Let's just say that's up there. Okay, call that x1. Call that red underlined one. And the other point, we have no clue where it is. Oh, but we do know it's at the same. Holy, is this true? Yeah, I was about to say, this is actually a pretty easy one, to be fair, but that's okay, we can do it. Because we know it's on this line somewhere, right? We just don't know where. It could be way over here, could be way over here. We don't know which of those blue dots it is. But we do know, whatever blue dot it is, the line is called x. Wherever it hits. Or maybe I should call it x2 to be even cooler. x2, the blue 2. Okay? And we know that the y value is 2 for everything on that line. And so it asks us for the distance between these two things is 8. I am going to set it up with the Pythagorean theorem because you could do it if it wasn't in the same plane. Even though this one's way easier, you could just look at this and say, how far away is 1 from 8?
I'm just doing math regularly.
I know. Well, how do we know which one it is? -9 or positive? It says distance and not displacement.
Distance.
Weird. Does it tell you what quadrant it's in?
Find x such that the distance between x2 and -1, 2 is 8 units. There are two solutions.
Oh. Yeah, that's what we were just calling. Yeah. Okay, I was like, unless they tell us like what quadrants it's in, that could help us. What does it say about them? You give either one or give both.
Give the one word. Put in the order that A is less than.
Oh, okay. So just go smaller to greater. Okay, no big deal. Let's set it up with the Pythagorean theorem because that is important. So we'll do. If you've got two general points, who cares what the points are? They're diagonal. You've got an x, y, right, and an x, y. And in order to find the distance between those 2 points, you just have to do the Pythagorean theorem. A squared plus b squared equals c squared, right? So let's call this distance for d. D is equal to the square root of y minus y squared plus x minus x squared. So long as you're consistent with your 2's and your 1's. And so let's solve that thing if we want to. So we got 8 is equal to the square root of, I'm going to do 2 minus 1, because that's what we always do. So we got x1, or call it p1 and p2, 0.1, 0.2. So I'm going to go 2 minus 2 squared for my y values, because that's the distance between the two y values, plus x minus negative 1 squared, distance between my x values. And so 8 equals, ooh, that's nice. 2 minus 2 just turns into 0. 0 squared is 0. So that side is like irrelevant. And then we've got x plus 1 squared. That's nice too. Look at the squared and the square root. Go away. 8 equals the square root of x plus 1. No, wait, we just got rid of that. Oh, shoot. Hang on, what? I've missed one of the solutions. Yeah, because I wrote the square root for the first time. Problem didn't write it. I wrote it for the first time. I need to add that plus or that minus. I need to add a big plus or minus around this, which means I need to go through and split it into two different problems. One would be x plus 1 equals 8. X plus 1 equals negative 8. I just moved it to the other side. Divide by the negative 1 if you need to. If you want to think of it that way. So x equals 7. And x equals negative 9. Definitely easier to do if you just logic it out and count. Yes, but that's the way you do it with the Pythagorean theorem. If they weren't the exact same y value. Yeah.
Question. What was the question asking? Because I spent too much time looking for the actual function on the paper.
Which one?
The one we just did.
It's not on the paper. It's from the homework.
Right, you said 2.6. I have the packet for 2.6. I didn't see it.
No, from the homework.
Oh! I'm tripping. Okay.
No, it's okay.
My bad.
It's okay. But it would be the very last thing on the packet, which is Pythagorean theorem.
Okay.
And it's just taking these two concepts that you've learned and mashing them together, even though the notes don't have it. The concept of the Pythagorean theorem and the concept of 2 points on a grid. So it is things you've learned. It's just applying them together in a weird way that takes thinking and practice. Okay, yeah.
Is this going to be on paper?
It's going to be on what?
Paper or laptop?
For the test? Paper. On Friday. Okay. Yeah, what's up?
I had another, this
Home.
one should be a quick problem.
But is it more like the test? Review? Never mind. Give us the problem. Someone else can ask a question if they want to.
What positive integer is 11 times its square root?
Oh, fun. What? So, call it I for integer. What I is an equal sign, sounds like. What positive integer is 11 times? 11 times its square root? Its own square root?
Yeah.
So the square root of I? Okay. That's fun. Well, can we solve that? Maybe. Let's find out. Oh, we can definitely do that. That's fun. What positive integer, I, is 11 times its own square root? Any thoughts on getting that I by itself? Square it. Do you want to move the 11 before you square it, or leave it there and square? Divide 11, you mean? That's what I was saying is, do you want to square it first and square the whole thing and get 11 to be like 130, 121 or something? Or divide it so you square something by itself? That is a you problem for your brain to decide what's easier for you to see. So if you're a divide person, that's totally fine and it's okay. You just go divide by 11. I'll do it both ways. Divide by 11, right? And now we're left with I over 11 is equal to the square root of I. What do you do with that square root? Square it. Got to square the whole side, right? This is going to be harder than it looks.
So question is, like, not really attached to the problem. Why don't you just subtract it?
Subtract what? The 11? Because it's multiplied. Subtraction is not the opposite of multiplication. Subtraction would be if it were added. In order to get rid of something, you have to undo it with the opposite. So now we're looking at. Ooh. Is this really a problem? 1 over 121 I, because that's 11 squared. 11 times 11 is a times table that we don't know. Equals I. Oh, it's not too bad. This is, wait, I squared. No, we can do this. This is not a hard solve. In terms of the quad, I thought the quadratic was going to get really annoying or whatever. All right, now how do we solve this thing? Yes.
I guess the way the question's worded is confused.
Okay, would it be better with an X? I'm not going to do it, but you can do the same problem with X. X equals 11 root X. X over 11 equals root X. Square both sides. X squared over 121 equals X. Now what? You want to move the 121 back over? We could. What are we always solving for? What are we always solving for every time? Yeah.
So why would we put 121 in there?
Just trying stuff. I don't know. I mean, we're not in a bad spot. This is good. We just got to figure out what to do. Explore. Yeah. Not right now in the middle of this. Thank you. After this, yes, 100%.
Do you want to divide the X?
Divide the X?
I mean,
If you do that, you'll only get one of your two solutions. We talked about this in class. We talked about, yes, this was a big problem in class where we said, there's a real temptation to do that to make the problem easier, but you miss out on a solution. So you get half the credit. You'll get 5 of the 10 test points or whatever, but you'll miss out on a solution if you.
so then the only thing you can really truly do is just time.
Sure. Now what? That would just undo what we just did. We just squared to get rid of that. No, we're in a good spot right now. We're getting closer. This is a closer to what we need to do. Yes.
No, minus 121x and then, oh, did someone already say it?
Now what?
And then you.
Now Emily knows what. Oh, but you can say it. I just saying we did this morning like 100 times.
Just
Factor out. What comes out of there? What's left?
Yay! Now there's 0 and
Now your zeros are x equal,
0 and 1.
which was I said at some point I was like, oh, these aren't bad solutions. Just bad to get there.
In order to find it, you gotta switch both sides.
Well, you didn't have to switch both sides, honestly. We could have just squared it straight up, which is what Mario said, which is you could have just gone like this. Square. But this is a real scary thing because squaring complex terms is kind of hard, like for people to know that you can distribute that square to both of those terms because exponents distribute across multiplication but not addition. FOIL is the exponents to addition, but exponents to multiplication, you can just send them. And so that ends up being 121x and you saved a couple steps. Or you could look at it right here and just move this x over right now.
I know this is gonna be like a dumb
I'll
question.
move the X over.
Subtract x.
Okay.
You could only just subtract x right here, factor out an x, get 1 over 21 minus 1, and solve that. Yeah, I don't, because of fraction. People don't like fractions, and that's fair.
So then-
Which is why when she said move it back over, I'm like, yeah, that might make it easier for us to see. And then y'all did. You said, oh, maybe move, maybe divide, or maybe factor. But yeah, it is hard. Go back and watch that. Go back and watch it tonight.
On here, it said the answer was just 121.
Oh, so 0 is bad? So we need to check it.
Oh yeah, because it's got a square root.
It does have a square root. But plugging 0 in works.
But the computer said,
Plug 0 in there. Plug 0 in there. Tell me what you get. Oh, does it say a positive digit? Or a Oh, positive integer. That eliminates 0.
That makes sense.
That's just the wording of the question, not the math.
0 is a negative.
If it would have just said which integer, then you could have done both. So that's just in the wording of the question. I don't particularly word questions like that on the test. It's more like what you see on the review. All right, Isel, sorry to keep you waiting. Did you have a question?
Yes. X to the fourth.
This is more like the test. Thank you. Those two great questions. A little less like the test. No, but they're hard. I told you the test is gonna be a little easier. Okay, keep going. X4
Minus 5x squared
equals.
minus 6 equals 0.
Oh, we've done this, and this is tough. Good problem though to ask. Okay, it almost looks really, really cool, but it's not. Right? It almost looks like a nice thing. And so here's what I would ask you to do. No, it almost does. I'm saying it doesn't. I agree. But what cool thing, and I'm going to ask you just to like imagine it does. What cool, easy problem does it almost look like? But which one specifically? Like you can look at that and kind of say maybe use W or maybe use X or not
I
X.
want to say the quadratic formula was like it's b squared.
Yeah, but what exact one with the numbers in it? Not the formula. Tell me the thing you wish this was. You wish it was X2. I don't want to use X though because X and X together. U2
U2 minus 5U minus 6.
equals 0. Don't you wish it was that? Don't you? It looks almost like that, doesn't it? Yeah, it is. So now we got to ask ourselves, well, where's the easiest place to see the substitute at? I always think it's right here. I think that's the easiest spot to see it. So what is the U that we're actually going to be using? Just X squared. And then you can ask yourself, oh, does that actually work in the first term? Well, let's see. Is X4 X squared squared? Yeah, so it's U squared. It's kind of where that works out. Okay, now can we, just using that green U stuff, can we factor that and solve it really, really fast? U minus, crap.
Like 6
3 and 2 does make 6, but it doesn't make 5. You might,
I would say 6.
oh,
Yeah,
U minus 6, U plus 1, hang on. So negative 6, 1, make 5. Boom, boom, make negative 6, yes. 3 and 2 are really tempting though because they do make those things. But depending on what signs you do, you can't ever get to 5 with a negative 3 and a positive 2 or a negative 2 and a positive 3 equals 0. That means U equals 6. That means U equals negative 1. But wait, we didn't want U. We wanted X. And so we say X squared equals 6. And X squared equals negative 1. Because we've taken that U sub and put it back in. Cool. So what you're gonna say just the answers?
Basically, just kind of like ignore the grouping number. Really?
Ignore the what?
So just kind of like ignore the grouping number and put it to what the problem would look like.
That's what I do. If it looks complicated, so like, but it almost looks right, put it in the normal, put it in what you wish it looked like, and then see if there's a U that works out real nice and neat. I got a problem with 2 of those solutions. Anybody see the problem? You can't have. Oh, I guess we could write that. Dang it! I was just gonna put a big X through. Yeah. Does this? Depending on whether it says real or not or whatever, this could totally be plus or minus I. Or if it says real solutions, it could totally be those are the only real solutions. Just to.
It says to find all the zeros. What is problem?
Zeros means the spot where y equals 0. I mean, like x-intercepts. Are you on it right now? You want to go ahead and try it with the no i's? Because I'm going to go ahead and say this is my guess.
I got 0.45. I have a point.
So it needed the i's?
Oh,
Did you do plus and minus? So it needed the i's?
yes.
Rats. I wish it said solutions. Solutions I like better for i's. Zeros is a weird word. Tell me the plus or minus I gets you full credit.
No, I multiple.
Oh, you got 45 because it was the third attempt or the fourth attempt. Was it the first attempt? Oh, yeah. Well, there you go. Dang it. Okay, well, freaking start over, do it again. Don't include the zeros. That's what I thought in the first place. No zeros. That's only if it says include imaginary solutions. Unless it specifically says, I also want the imaginaries just for fun, you can include them. But I would say most of the time, 99.9% of the time, particularly in this class, don't include imaginaries unless it's an imaginary problem. Like that one on your review somewhere in there where it has the eyes already. All right, let's keep going because we only have 20 minutes left. And I'd like to get a few more test review questions instead of homework review questions. What?
On the test review, x and y intercepts, how do I find the y-intercept of
Ooh,
equals -6?
The y-intercept of x equals -6. The first thing I would do is, actually, let's just review this real quick. There's an acronym that I really like called HOI-VUX. HOI-VUX. If you can remember that, all of these weird ones are going to be way, way better. HOI stands for horizontal. Slope m equals 0, or slope, I don't know, 0 slope. And y equals format. V stands for vertical. Undefined slope. And x equals format. So HOI-VUX. Horizontal, y equals vertical, x equals. So what kind of line is this?
It's just a straight line that
X equals format, so it's vertical. And so you figure out, what does a vertical line look like? It looks like this. Move it around until you get it to the spot. So this is the only way you can move a vertical line, right? You can't like spin it. So this is it. So what does that x, this stuff up here, x equals -6, tell me about this vertical line? What am I looking for? Where x equals, we don't have lines, but yeah, somewhere around there, right? If that point is -6, comma 0, somewhere like that, right there. And so that's the line. That's the Cartesian grid. And what was your question? Where's the y-intercept? Okay, well, where's the x-intercept at? Right there. So the x-int is -6, 0. And the y-intercept, where does that line cross the y-axis? Never. Look at those two lines. Yeah, that line is parallel with the y-axis. So you write none or NA or whatever the homework tells you to do. Or in my test, you just write no y-intercept. None. Y-intercept, I don't know. That's a good question. Because I do find that those problems are easy to do, but they're easy to get tripped up on too. The horizontal and vertical straight up ones. They're not hard to do because there's no math here. But they're very easy to get tripped up on, right? X equals instead of y equals. It's the same argument. But yes, y equals, I look over here and I say that means horizontal, right? So I draw a horizontal line. And in my brain, I know you can't do this. I just move it up and down until I see, oh, this is not going to have a x-intercept, and it's going to have a y-intercept at wherever you just said. So where did you say? Y equals 4. So I'm going to go up until the only place it's ever going to hit a 4 number is right there-ish. And that point is, you got to know your points.
0, 4.
Yes, not 4, 0. 0, 4. And so what was your question? What's the intercept? That. What's the x-intercept? None. Cool.
Can we try some complex numbers?
We should. So anything with complex?
It's like divine express and standard for
Yep. Give me the one that looks the hardest. Oh, I can go up there and just copy it, actually. Yeah, 100%. I don't think that will be the one that makes it, but if we can do that, we can do the other ones for sure. We're going to do dividing complex numbers. We're going to do D, and then I'll leave you to practice A, B, and C. I won't copy and paste. What do I do? Maybe this? What the heck? Sometimes it works. Oh, this is why I won't do it. I'm dumb. That was on me. That one? Yeah. All right. Step 1. I gave you the steps on this one because this is the first one, right? Oh, no, this isn't the first one. Well, step 1 is find the reciprocal. Or no. Bad word. Not reciprocal. Conjugate. So what's the conjugate? Yep, because you're supposed to flip the middle. You don't flip the middle. You're not flipping the middle. You're flipping the sign that's in front of the I. Don't flip the middle. I'm really scared that's going to happen. On the test I don't make, or the test I do make, to be mean. You flip the I. You don't flip the middle. Don't be, if it looked like this, negative 3I plus 4, you do that. Okay, don't flip the middle, flip the I. That's just me being scared. Okay, so then we multiply by that, right? And then multiply by the bottom, but you're not allowed to just multiply by things willy-nilly unless those things are I, or 1. So there's a 1. I would point out, because we were talking also this morning in office hours about some of these things should work out. Some of these things should turn nice and neat. And the reason we picked that conjugate is so the bottom would turn out nice and neat. If it doesn't, start over and try again, pick a different thing, or check your factor FOIL. So I'm going to do the bottom first because the bottom's supposed to turn out nice and neat. We don't have any guarantees about the top because that's just random. But the bottom should always turn out nice and neat because that's the conjugate. That's why we picked it. So here we go. The first term of the FOIL, I'm going to do this in a single step FOIL to be, I don't know, we're just getting better at math. 4 times 4 is 16. So that was, I'll label it, but I'm not going to do it out to the side. F, outside, plus 12I is the outside. Mine, oh, that's so nice. Minus 12I is the inside. Minus 9I squared is the last. Just chucked it. It's so funny. All right. One nice thing happens there. Don't say the word. What happens there in the middle? They turn into the equal to 0. They don't cancel each other. That looks a lot like they're canceling. Okay. Ooh, something really cool happens here. I squared is technically not I squared. It's technically negative 1. So I might rewrite it right next to it if y'all are cool with that, even though we haven't even done the top yet. 16 minus negative 1, which is just 16 plus 1, which is 17. The bottom worked out nice and neat. That's good for us. What? Oh my goodness. Why did I do that? Guys. Negative 1 times 9 is like that? 25. Thank you. Oh, that's even neater, actually, because that's not prime. All right, let's do the top now. We got to do the same FOIL thing. No guarantees this is pretty. I think it's not going to be. Negative 2 times 4 is negative 8. Outside is negative 6I. Inside is negative 40I. Last is negative 30I squared. All right. Can we go ahead and flip the sign on this 30I squared? The I squared is just going to make us flip that sign. And you can do that once you get C and Y instead of just once you see do it a couple times. So it'd be 30 minus 8 is 22 in the front. Minus 46I. So 22 minus 46I. I do think it's important to point out this is not, what did it say, standard form? There is a standard form and this is not it. And standard form doesn't just mean reduce. Standard form is a specific thing where you have really specific, this is what we were talking and hated on the homework, where they made you type it in 2 different chunks. They said type in A, type in B. Remember on the you know what I'm talking about? And they didn't even make you type I. They just wanted the coefficient for each one, for the real part and the imaginary part. The reason they do that is because so when you get to this, your brain says, oh, that looks like one big thing, but it's actually 2 things. The 2 things are 22 over 25 minus, and I'm even going to write it a little cooler so you can see what you should have typed in the homework. What you should have typed in the homework would have been 22 over 25 and then negative 46 over 25. And the I is just hanging out. And yeah, if you want to label them because this is a complex number or what you call standard form, you can call this the real part and the imaginary part. I'll zoom out because I went fast there. Oop. All right, we probably have time for one more, but I also need to check roll before we leave. You didn't remind me? Are you just waiting on it? That's all right. Yeah, dude.
Oh, I have a question.
Yeah.
It's about completing the square.
Yes, we should do one. What's up? We should do one because we don't get to do this very often. What you got?
We just did it on holiday yesterday.
Holy smokes. Never mind. I thought they added a bunch of options, but I clicked the wrong thing. I can't make one up. That's the only problem I can't make up because it's got to be like perfect. Anybody got a completing the square problem real quick? I don't know how you would have one real quick, but
24 is all on the back.
but do you know that it square complete? Give me the numbers. We'll try it.
Okay, x
X squared
squared minus 6x equals
minus 6x equals 19?
13.
13? So we should move oh, they've already moved it for us. Normally, here's completing the square. Normally we would need to move that constant over. They already did it for us. So now what we're looking for, and I'm not texting, I'm getting to the roll. Now what we're looking for is that nice, neat number that would make this a really, really easy factor. So looking over here, we're going to say, here's how you find that nice, neat number that makes a nice factor. You take the 6, you divide by 2, which is what?
Squared.
3.
6 divided by 2 is square.
It's -3.
Thank you. But then, yeah, it wouldn't even matter if you messed that up. And then you take that and you, I don't know how to write square it. I guess just -3 square. And then you square it, right? Okay.
Add on both sides.
Yes, yes.
And then you'd go x squared minus 6x plus 9. But wait, you're not allowed to just plus 9 wherever you want. So you have to do the other side. And you are allowed to do that. Because if you were to subtract it from both sides, you end up with the same exact thing. So now we've got x. You picked that number because it was really cool. Why was it really cool? X minus 3 makes a -3, -3 make 9. -3 plus -3 makes 6. That's really cool. Equals 21? Oh, thank you. And now you just solve that. You're home free to solve. Square root it. Really important, though. This goes back to what we started this today with. What did we just do for the first time in this problem? We wrote the square root. So we need to write a plus or a minus on one of the sides. I'm going to put it over here because it's just easier. So x minus 3 equals... That's awful, actually. It's fine. Plus or minus root 22. 11 and 2 are not factorable. Or they are, but they're both prime, and neither of them are squares. So 22 is staying for the rest of the problem. You're never doing anything with it. And so x equals plus 3 kills that, right? Put it in the front so it looks prettier. 3 plus or minus root 22. Yeah? We completed a square? Will? Well, here, I'll stop this and then we can do roll. Let's get started. Yay. All right, we're recording. We can save it, sure. All right, we're here. Does anybody have any places they got stuck or had a question they absolutely knew they wanted to ask as they were going through their review?
Could you give us the steps for complex numbers?
You mean, is that what the name of I made the name of it complex numbers? Oh, I guess I did. I guess that should say dividing complex numbers technically because that's what that problem is, which is fine. Complex numbers is fine. But yeah, if you want to be more specific, this is the steps for dividing complex numbers, not just complex. Because multiplying and adding are kind of, I think you know how to do it. Like adding is the easiest one. It's just normal, right? Multiplying, you have to remember I squared. But dividing is ideal. Okay, so the steps. Step 1, I think there might just be 2. Oh, just bit my lip. I think there might just be 2 main ones. Anybody know the first one? Yeah. It's just like identify or determine or... I'm just going to write the word conjugate. Oh, maybe not just write the word conjugate. Which one of the 2 things do you conjugate? Yeah, I'm even going to write the word bottom. It's called the denominator. But maybe you're in here and that's going to confuse you more. Conjugate the bottom. Conjugate bottom. Flip the sign of the I on the bottom. And then what do you do with that conjugate? Multiply. How do you multiply by conjugate over conjugate? And that conjugate comes from directly above. And then pretty much those are the two steps. All the other stuff is just falling out of that. So we did, I know it looks like the hardest one, but we did D in the last class and have it on video. So I might try to do a different one. Maybe C is the next hardest because it's got two negative signs. Just so that we're not wasting time on the video if someone does go home and watch them. Good afternoon, morning. Did you go up the stairs?
Yeah.
I'm so sorry. I did send out a group me, but I know nobody checked, or not everybody checks the group me. I should have sent out a Blackboard announcement too. I just got word like yesterday. So this is, for this class, this is like permanent. We're in here, and I'm in here before, so I don't have to like carry all the, when we do craft stuff or rocket ship stuff or whatever, we can just be here, which is great. Okay, let's do this then. So we said the first one is to determine the conjugate of the bottom. I know that's a big word. So what do we do to find that conjugate? We flip one of the signs. Which one? The one with the I, not the one in the middle, even though it usually is. We flip the one with the I. Nope. So that I just did both steps in one. Step one was, what is the conjugate? And step two was, multiply by it. And here's a question for anybody that wasn't just in our last class is, why did we pick the conjugate? I just answered it in the last class, but I think it's worth asking, so it's kind of fresh on our brains, is why do the conjugate? Why pick that one? It's okay if you don't know. There is a reason we picked it and we didn't just multiply by any random number. That's like $20. $20 is the person who has even a guess. You don't have to be right. Why did we pick that number? But why did we pick it? Why did I tell you at the beginning of the year, pick the conjugate for this?
I was gonna say to eliminate the negative, but sometimes.
Yeah, no, it always will. It eliminates the negative? Oh, you're talking about eliminate this negative. No, because sometimes it makes a negative. It eliminates something. Yeah, it's going to get rid of the I. And you know what else it's going to get rid of? The two terms in the middle, because it's the perfect number. Watch. So this is why we do it. We do it because it makes our life the easiest, not the hardest, even though it looks ugly. So I'm going to foil. I'll foil a little faster than normal. So I'm going to start with the bottom, because the bottom is the prettier version. What's negative 8 times negative 8? 64. That's the first term. Outside. What's negative 8? These are all going to be 64. What's negative 8 times 8i? Good call. Negative 64i is good. That's the outside. Inside? Ooh, positive 64i, because the two negatives, right? And then last is negative 64i squared. And that came straight out of, if you're like, what the heck did you just do? That came straight out of negative 8 minus 8i, parentheses, negative 8 minus 8i, parentheses, first, outer, inner, last, FOIL, that thing that we do sometimes. The first, the outer, the inner, and the last. Something really nice and neat just happened there. Anybody see something really cool that happened in the middle of that? Isn't that cool? That's why we picked the conjugate. There's two reasons why we picked the conjugate. That's one of them. Anybody else see something nice and neat that happens there? Or not nice and neat. It's actually ugly, but it's going to make our lives better. I squared. Whoa. I squared is not actually I squared. I squared is actually negative 1 forever. Okay, so I'm going to do one more step just to make it a little prettier and say, on the bottom we have 64 plus 64. Because that negative 1 is just going to flip the sign in front of it. And so it's like 128. And that's why we picked the conjugate. Because all that ugly stuff turned into one regular number. That's what the conjugate's good for. Now, that's not going to happen on the top because we didn't conjugate the top. But that's why we do it. But actually, this top is way better than the other top because we don't have to FOIL. We just have to do what word? Distribute. And we end up with negative 32i plus 32i squared. I squared does the same cool thing. This is actually not I squared. It's actually, which is actually not negative 1. It actually just flips the sign in front. And now we've got, I'm going to flip these around so they're in the standard form because I think it asks for standard form. Make sure the i's on the back and the numbers in the front. So we've got a negative 32 minus 32i. So negative 32 minus 32i. And we are not yet fully in standard form yet. We need to do one more thing, and it's not reduce. We do also need to reduce, but if you don't reduce, it's like neither here nor there. It's a little annoying, but you should reduce. But we need to do one more thing to actually get it in standard form. And this comes straight out of the homework. Remember on the homework where it had you type it in 2 different sections? Like it didn't even make you type the I. It just made you type, I think, an A and a B or maybe a R into something. I don't remember. But it had A little space for answer, B little space for an answer, even though it was a number like this. That's because it's 2 different things. It's a real thing and an imaginary thing, and they have to come apart. So you have to go equals negative 32 over 128 minus 32i over 128. So you have to split them apart because one of those is real and one of those is imaginary. There's a real part and an imaginary part. And now we should probably reduce. Is it just by 2 or is there something better? I'm not good at this part. 16. Wait, what about 32? Someone. Does it work?
Yeah.
Times 4? Oh, duh. 128 and 4. Yeah. So negative 1 over 4 minus 1 over 4i. Zoom out. Leave it here for a second so you can look at the whole thing. Also on the video, you can pause it. If you're watching the video later tonight, pause the video, look at it, see if you can work through it. Try a different one like it. Oh man, we should have done that at the beginning. You know what we could have done at the very, very beginning of this to make our lives like infinitely easier? 488. Could have made it down to 122 and then done the same thing. That would have made life like way better. I didn't even think about that. Factor out of 4, factor out of 4 here, cancel out the 4s. That would have been awesome. Dang it. Yeah, you want to try this again later at home with a much easier way? Do this right here. Factor out of 4. Factor out of 4. And you'd get something like 4i over 4 negative 2 minus 2i. Those 4s turn into a 1. And now you can just do it with that thing, and life is way easier. So that's pretty cool. I didn't even think about that. All right, thank you. Good question. Over. Appreciate it. Let's keep going though. If you got one from your homework, got one that you got stuck on, do holler and let me know. Yes, because we didn't do it in class. It was just assumed, but I put it on there because it's the only one that we didn't do that I was like, this is actually really important for just ever in math. Yes, thank you. I might just go ahead and put them up where it was. Oh, I don't have that because I fixed it on y'all's and not mine. Will you go ahead and tell me what number it is and I'll just write it? It's 8.
Yeah.
It's 8. It's number 8. My paper looks different than yours on here, so I'm writing it at the bottom. Sorry. This is the X and Y intercept rules. Actually, there's really easy. There's just 2, one for each. For an x-intercept, actually, anybody know? I think it's 3 words. No, it might be 4 words. But how do you find an x-intercept? Yes. I'm going to say plug it. Change y to 0, or plug 0 into y. That's it. And then you solve, and then for a y-intercept, now you could definitely guess what it is. Plug 0 into x. Anybody want to hit me up with a problem and we can do it? Just as one little example? Because I don't have it in front of me.
4x minus 3y equals 12.
Which one you want to do first? Does not matter to me. Do x first, which means we plug 0 in for y. So 4x minus 3 times 0 equals 12. 3 times 0 is 0, so 4x equals 12, which means x equals 3. But pause, x equals 3 is not an intercept, it's just a fact or a statement or whatever. Anybody good at writing intercepts? That's what I was asking. Is it 0, 3 or is it 3, 0? You tell me. Which one's x, which one's y? 3, 0, because x goes first, then y. And we already said y is 0 up there above whenever we did our first plug-in chug. So y was 0 and x was 3. And that's where we got our 2 points from. You think you're good on that? So you can get y by yourself? Cool. What? It's pretty, yeah, it's exactly the same. Plugging in 0 for the other one. All right, what else are we looking at? Sad day. Anybody just not study or work on it yet? Anybody not look at the review yet? No shame. It's okay. Thank you. Appreciate the honesty. Flip through it now. This is a good time.
So on the textbook one, there's one that says like find something passing through 4, 2, 5.
Parallel or perpendicular?
I'm sure.
Does it say that?
No.
Oh, just a line passing through a point?
Yeah.
That's totally valid. Yes, let's do it. Which one? What number?
15 on the textbook practice test.
Oh, yeah, 100% a question that could be asked. There's 2 steps to this. Wait, don't we have one of those up there too? Right there. So we have steps for it too. Determining the equation for a line. Find the equation, pass it through 2 points. 100%, really important. There's 2 or 3 steps maybe, depending on how you go about it. First step is m equals what? That's step 1, is find m. Step 1, find m. Sometimes the problem will give you m in 1 point. Then you can skip step 1 because you found m. Step 2, use the harder of the 2 formulas. Use the longer of the 2 formulas. Use the y minus y1 equals m x minus x1. Plug in m x1 y1. No, that's just to get a form. That's the equation. That is the equation. And the second one is maybe solve for y. This gets you slope intercept. The red step gets you a different name for a formula, but it's still a formula. Anybody remember this name? Yep, point slope. And cough, cough, if you're taking your test and it has 2 little boxes and it says one's point slope, one's slope intercept, find both. You actually have to find both and put them in the right spot and know which one's which. So this is the order. This is not 3 random steps. This is the order of the steps. You can't get to slope intercept without finding point slope. So let's just do one of these. Let's do one with a bunch of negatives because that'll make our lives harder, which is good. So let's do C, I think. I'm just gonna do it up here because I'm getting lazy. First things first, we gotta find that slope. M equal what? M equals what? 5 minus 2 divided by minus -4. So 3 over plus plus. 3 over 1. So 3. Oh, nice. That's nice and easy. I'm doing this one just so we know. I'm not just starting randomly. So step 1, we found our slope. Step 2, we plug our slope and a point back in. How do we know which one to use? How do we know which one of these 2 points to use? What would they give us 2 different equations? No, they shouldn't, right? If they do, that's bad. They should get you the exact same equation, even though they look very different. Don't know how that works out. It just always does. Yeah, that is funny how it works out. How it feels like if you're just plugging in 2 random numbers, which these look very different, and a random slope, they would get 2 different equations. They don't. They get the exact same equation. Oh, that might actually be fun. Let's plug it in real quick. So, y minus, which one do y'all want to use? Okay, girls, who just said that? You said that, Nika? Girls use the wait, what do you mean by 2? Oh, you're saying this one right here? All right, girls use this one, boys use the other one. Let's get to an equation together. So split apart, and then we'll come back together at the end. So we got y minus 2 for the girls, and then boys, you use the other one. Blue for boys, red for girls. That'll be fun. Or just do whichever problem you want to do. Whatever. Equals, our slope is m, so we're plugging in the slope, times x minus a -4. So we got y minus 2 equals 3x plus 4. That is our point slope form if you're a boy. And if you're a girl, your points, wait, no, vice versa. The other point slope form would be y minus 5 equals 3x plus 3. Anybody else? All right, now both sides of this table solve for y by itself. I think you got to do a distributive property and then a move one thing and you're done. So solve for y by itself. I'm going to go with the boy side because I'm a boy. Done. For the boy side. Tell me if anybody gets the red side. I'll be pumped. But don't look at mine. Don't cheat. Did you get it?
Oh, the slope intercept or the point slope? No, I got that. Yeah.
For slope intercept? And for point slope, probably. Did anybody do the red one? You got the same thing? For point slope or for slope intercept? Yeah, but not for point slope. They're 2 different, or they look different in the point slope formula. That's okay. So as we're going about and you're taking your test, there's going to be 2 correct point slope formulas for that section, but there's probably only going to be 1 slope intercept that's correct. Kind of an interesting way that works about. Distribute the 3x, 12 plus 2 is 14. There you go. Yep. All right, let's keep going. Maybe do one. It's a good question. Really important. You could totally go back and find the x and y intercepts now, but with the same formula, and that's a random equation. Totally allowed to do. That's about all you could do.
How would you find the intercept if it's just like y equals 4?
Same way. Plug in. So if it's y equals 4, which one's which? Okay, plug in 0 for y to get the x-intercept. So 0 equals 4. What is that? Is that okay? No. So there is no whatever you just said. X-intercept. And for the other one, there's nowhere to plug it in, right? And so that is the y-intercept. Or, yeah, the y-intercept is 0, 4. Another way to look at that is a really good question. So you have an equation like that, or you have an equation like x equals 3. There's a acronym that I really like, which is Hoi Lux. I don't know why. It's just something I've heard all my life. Since it's like Algebra 1. Stands for horizontal. Horizontal. 0 slope. And y equals is what it looks like. So y equals is a horizontal line with 0 slope. So that one looks like this. You just draw a horizontal line. You click on it. You say, where does it go? Where does it go? Well, it goes where y equals 4. I just go until I think it looks like that's like y equals negative infinity. That's like y equals 0. So y equals 4 is somewhere up there. And now you can a little bit better see what the intercept is. The intercept looks like it's 0, 4. And where does that cross the x-axis? Nowhere. There isn't one. So the same thing happens for vertical lines. You could totally just zoom. Vertical stands for vertical, undefined slope. There is no slope, and x equals format. And so that one probably is somewhere like right there where you have the point 3, 0, and no y-intercept. Really fast rundown of those two types of things. Hoivux, though, helps me remember the y. Really, the Hoivux for the best thing is for the. I don't even like the middle sections that much. I like the y equals and the x equals at the very end to know which one's vertical and which one's horizontal. That's what it helps me with the most. Is as soon as I see a horizontal line, I'm like, oh, y equals. Now let me go look at the y. So Hoivux helps me with that a lot. Okay, what else we got? There's a lot of hard ones on here, and those.
I have a question.
Yes.
For the quadratic formula, you said 3 of them aren't going to have a solution, right?
I don't know.
That's what you said. Correct.
3 of them are not going to have a solution?
You said some of them are going to have a solution on the review. I'm not sure.
I don't.
Because I remember, I think the one you did you do one?
No, we were talking about rational. We were talking about this one having no solution.
Oh, radical ones, right?
Yeah.
Those are the ones that were going to have a solution?
Well, this one. I don't know about the rest of them.
Oh,
I've only done this one. You're supposed to do the other ones. This one, yeah, there was no solution. We got down, I think, to r equals -1, but then when we plugged it in, it was bad. So this one had a solution. I think this was like 64 or 61. Yeah. I don't know about these two. I haven't done them yet. Do them. Try it out. See what you get. This one looks like it might be like 5. 4 minus 15 is no. 4 minus 2, 6. 4 minus 6 is 36. Square root is 6. No, that doesn't work. What about 7? 21? No. What about -3? No. Okay, square root of 7. I don't want to do it. We can do it later. Somebody hit me up with a new problem for us to do. Chapter 2, test review. Is there one on the review? There's not one on the review, but we can totally do one because they're still. Yeah, I was just thinking about it. I don't think we did them in class. Yeah, I don't think we got that low in the textbook in class. So here we go. Maybe we did one. I don't remember. Oh, that's so ugly. Okay. So absolute value work out a lot like the equal sign did. Remember what we did with the equal sign where we just drew it on both sides? It's exactly the same. So we did it. I know at least we've done absolute value equal sign. So when you're working with this 2x plus 3 is less than 5. Do you remember kind of what we did with an equal sign? I mean, we do draw the line down it, but how do we get rid of the absolute value sign? We put another one on the left, and we drew the same sign, right? Boom. It's the same way. We just have to be a little more careful with absolute values because they can flip around if you divide by a negative, still there. And then they can also give you a little like false reality with where they are. So the false reality might be, well, you'll see. Maybe we'll hit one, maybe we won't. So that gets rid of the absolute value by putting that thing over there. So now we're just greater than 5, 2x plus 3, less than 5. Get rid of the 3, right? Get rid of the 2. I believe in you. So x is less than minus 3 minus 8 divided by 2 minus 4. And is greater than plus 3, 8, 4. You cool with that? And now we've done something that looks like this. Because this is pretty standard stock normal. This is just a line. Open or close circles. Open circles at negative 4 and 4. And x is in the middle of it, right? Don't forget, it's totally okay if you want to do like parentheses with a line between them, because that's what our textbook, I think, does. Or something does, but they're both correct. I think our homework does these circles and our textbook does the brackets, and I just want them both to be similar. Did I mess up? Minus 3. Oh my goodness. 5 minus 3 is 2. Divided by 2 is 1. Why did it take so long? You knew that a long time ago. I added 3. So when you do it in your brain, you mess up. So don't do it in your brain, dude. Don't do it on paper. Do it in your brain, make mistakes like that. That was a test. Extra credit on the test. 5 points. 5 points on your test if you remember to tell me. Cool, that's fun. Thank you for asking. Because yeah, I don't think we hit one of those. And it essentially does boil down to this thing over here. Adding that to that side. I think it's worth. Confused. Are you late? Oh, okay. Yeah. I thought that's why I was confused. Sometimes this gives you a lie. Like, can we do the other one and just see if it gives you a lie? 3x minus 2 greater than or equal to 4. We don't have to do the whole problem. I'll let you work on it. But sometimes it gives you a lie, and that's important to see. So great. Yes. So what sign would we write? This is a good example of one. To get rid of that absolute value, what symbol might we write there? This one right there? And what goes on the other side? Okay, this is right. You did it correctly, but it's going to feed you a lie. 3x minus 2 is greater than or equal to 4, but less than or equal to negative 4. How is that possible? Give me a number that's greater than 4, that Pac-Man eats, that's bigger than 4, but less than negative 4. It's not possible, right? Okay, and that's okay. We just break it apart into 2. It's 2 different statements. It's not one statement. So we just, from there, when it gives us a lie, and actually, I don't even know that you have to identify the lie yet. You could identify it at the end of the problem still. So we could still work it out normal style. Plus 2, plus 2, plus 2. Negative 2, 3x, 6, divided by 3, divided by 3, divided by 3. This one's just harder to see than earlier, but that's okay. So I ended up with x is less than or equal to negative 2 over 3. Is less than or greater than or equal to regular 2. And that's a lie. It can't be less than a negative and greater than a positive. So it's 2 different statements. And when you go to your number line to graph it, you just graph it as 2 different statements. So you have a point way over here at negative 2 over 3. And you know which way the arrow goes? Less than. Because it says x is less than negative 2 over 3. And then you have a different color, I'll do it blue, where x is greater than 2. Totally allowed. Just looks like that. So yes, there's no one x value that fits both those, but there's a bunch of random x values that fit one or the other one, and that's okay. Cool, thank you. I really appreciate you asking that, because that is getting into the weeds a little more than we did in class. That's like harder than class, but in the book, it's still totally a real math question. All right, we got plenty of time. What else are we looking at?
So could we put Pythagorean theorem questions?
Could there? Yes. Likely, no. Should you know the Pythagorean theorem? Yeah. But I don't think so, if I'm being quite honest. Here's the review. A squared plus b squared equals c squared. It usually works it out. Most common in distance equals the square root of a squared plus b squared. That's the most common. Or even more specifically, distance equals the square root of y minus y, which we see all the time, plus x minus x, as long as you keep that y and that x consistent. That's the distance between two y things and the distance between two x things. And the Pythagorean theorem is the distance between those 2 points. So that would be like, instead of finding slope, there's your change in y. There's your change in x. And instead of dividing those two numbers, you're adding them, squaring them, square rooting them, and then finding the distance between two, which is completely different than slope. Distance is not slope, but it kind of looks like it. It's actually how far they are apart, not how steep they are if they were a roof. All right. Yeah, but no, but the answer to the question is probably not. It will come back in, I think 4.1, so we still have all chapter 3. 4.1, I'm pretty sure, is linear functions, and that's where that comes back. All right, what are we doing?
Can you do rational equation?
B? Didn't we already do that?
No, the first one.
A?
Like,
Oh, I thought you said radical. Sorry. Yes. Shoot, 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 shoot. Lowest common denominator, or remember, okay, yeah, we have talked tons about this, and this is weird. There's 2 major ways to do it. You can do lowest common denominator, or you can multiply across the top by the whole denominator. There's not one wrong or right. I don't know which way is easier. It's just different for different people. I think Emily does, you just multiply across by all 3. Not a bad thing to do. Say it's always going to work. Just might have a little extra reducing, but you know what to do right away. So what Emily or a lot of people that I've taught like in office hours or whatever will just multiply by all 3 things across the top, and it's just super safe because it's going to happen every time. No matter what the bottom is, that will work. If you are more of like I want to be fancy or I want to do something cool, you can identify the lowest common denominator, not just any common denominator, which is in this case 8x, and say how do I get to 8x on every single one? So that would be multiplied by 4x over 4x. That'd get you 8x on the bottom. And multiplied by 2 over 2. Get you 8x on the bottom. And that's okay too. It's just identifying that common denominator and using it is a little trickier. Like for D, if you look down 2 problems, where it's like ugly. If you look at the paper and you look at the 4th one, it's way uglier than doing it here. And so that's okay. It's just a thought. So as you get through that, you probably get something like, I'm going to do it this way because I've already got it on the paper. 4 over 8x plus 4x over 8x equals 22 over 8x. Nice. You know what all those 8x's do? They get to go away. Kind of. I'm going to say kind of for a real specific reason. They kind of go away. Because as I write that step, my brain should be like, shh. There's something really important to make a note of. As I do that, there's some really important thing that my brain should go. Side note, put a pin in this, and I'm just going to hold on to it for a long time. Though it might never come back, and it probably won't. Anybody know what that note would be? Between this blue and this red step, there's a really important note that your brain just has to put a pin in and say, I'm going to hold on to that because it might come back to bite me. It's from 3rd grade. Maybe 4th. When's the 1st grade that you learned division? Feels like 3rd. Like multiplication and division is 3rd. Okay, so 3rd grade, you're learning about division, and your teacher says there's this one thing. Can't divide by 0. And right here, what would make that happen? In the blue step, what makes divide by 0 happen? What number? So our note is x better not ever be 0. Because that would make us divide by 0 here, divide by 0 here. That would be bad. But look at this red step. What makes us divide by 0 on the red step? Nothing. We kind of eliminated it. With good math, we multiplied by 8x all the way across the top and got rid of it. But we eliminated one random weird condition from the 3rd grade with good math. Hence the side note of, hey, I'm going to finish solving this. But if I end up with at the end of the day with x equals 0, that's not possible. Also something you find while your teachers always stress, check your work, check your work, check your work. Because little things like this happen all the time. They happen in square roots. They happen in whatever this is, rationals. Let's keep going. So we got 4x equals 22 minus 4 is 18, right? Or is it 6? It's 18. So x equals 18 over 4. Reduce it a little bit. X equals 9 over 2. Pause. Does that violate the note that we made? We said x can't be 0. It's not. It's 9 over 2. We're good to go. Circle it. You're done. But the note is important. Very rarely does it come back, but it is important to make. Oh, this is like the perfect amount of water. All right, who's got the next one for us? Everybody gets to go home early. Everybody has to stay way later. Extra 10 points on the test right here. Everybody in this class and the 2 people in the other class that are extra. Wow. All right, what are we doing? Give one more, maybe 2 more. What? Well, it's up here. By that thing? Yes, but I would write it in a cool way first. The cool way to write it is x minus 2, x plus 1. Those are the same thing. Never look at this again. Now, if you multiply across by that green thing, it's going to cancel little stuff here, cancel little stuff here, cancel whole stuff here, and then it's a normal problem. With the side note, so the only thing is that's a normal problem once you do that, but there's a note here. What's the note to make here? X better not be 2. No, 0 is fine. 0 minus 2 is negative 2. Totally fine. X can't be 2. And here, x better not be negative 1. Which is kind of the opposite of factoring. Back in the day when you did this factor right here, you'd look at this and you'd say x equals 2. Yeah, that's true. If it's a 0. But if it's on the bottom, it's a bad number. Or it's a domain restriction. But more on that way later. We're going to do actual, this is why we're talking about this softly, is because there's a whole 2 sections in our next chapter that's called domain and range, where we look at actual domain restrictions from the square root, from the division, and from a couple other things, logs and exponents. But yeah, those are your 2 notes. That's your thing to multiply across the top. Let's keep going. We got about 5 minutes. I'll pull. What's up? Oh yeah, there's so many. We were talking about that today too, in office hours. So they're random, because some of them have the first one and some don't. But I know the first step that I would always do every single time for factoring. This is that factoring section. I would say the first one, always, always, always. I don't know why I put a bullet. There's already a dash. Is look for. I don't know what to call these things. Common. It's not even terms, because they're not terms. Common, I'm going to say terms, but they're factors. They are reverse, bless you, distributive property. And I don't know exactly the best way to say that, but this is what I would always do first. Sometimes it will happen, sometimes it will not. So the good example is on A, it happens. Is there a common term in A that you can pull out of there? There's an x, right? And if you pull an x out of there, what are you left with? I'm not going to do the whole thing, but I just want to get them started for you. X squared minus 16. And now if you're looking at that, you're like, oh, that x squared minus 16 is a special one. We did talk about that type, but So that's the first thing I would do. That blue step, look for common terms. But sometimes it won't happen. Oh, crap. It happens in B too. That's what I'm saying. In C, it doesn't happen. Is there anything in common in C? No, so you can't do that step. That's what I'm saying. Sometimes the steps are there, sometimes the steps aren't there. But I still do that first because it makes your life easier. Okay, so then the next step is I don't know. It's not really steps because there's like a bunch of different types. Maybe we should just identify the types. There are perfect squares, right? Those are going to be like x squared minus 16 plus 4 minus 4. There are, I'm going to call these easy ones. I need to make up an easy one, and that's kind of hard to do, like x squared plus 2x plus 1. 1 and 1. 1 and 1 make 1, and 1 and 1 make 2, right? So those are the ones where you can do it underneath, and you can just say, well, what times what equals what, and do they add up to the middle? What else are there? There are slide and divide ones. But other people have other ways of doing those. Some people call it the AC method, which is that like X thing where they draw an X and they do stuff in it. I don't know how to do that, but if somebody does and they want to teach you, go to the library and learn it. Those are the little bit harder ones. Those are what the C, like you're talking about with C, because I don't think C is a nice, neat factor. So you'd have to do 3 times 4 is 12. And now is it a nice, neat factor? 12 breaks out into 4 and 3? No. 6 and 2? Negative 6, negative 2? But that's not your answer, because now you have to do what? Divide by the 3, right? Sorry, there's not enough room here, but I'm doing it anyways. Reduce it first. Don't slide it to the front first. Reduce the fraction first. So don't slide this 3 to the front, because that fraction is a perfect fraction. Turns into x minus 2. And then the other one, now we can slide it 3x minus 2. So that's that one done really, really fast because we're running out of time. I don't think there's another one that I can think of. Oh, yeah, there's one more. If all else fails, what's the last step that you can do? Oh, no, that's the third one. Thank you. You can also complete the square. And if all else fails, what do you do? Quadratic formula. Quadratic formula always works every time, and it even yields you your imaginary answers. So I think those are the steps. That middle step is just try to see if there's a nice one. I think we might have left one off. I don't remember what it would have been. I don't know what the other one would have been for factoring. But if you look through section 1.6, I think it's called other types of factoring, that would give you more info on that. Don't leave, please. I got to check roll. No, don't hold that.